Happy June, everybody. Welcome back. So today we're going to be talking about solving trigonometric equations, and we might need to do some simplifying of trig expressions first, or using different types of triangles or different methods to solve these things. First, I have the identities listed from the last class. I just have them all written down. We have the tangent identities in yellow, so tangent of x and cotangent of x. We have the reciprocal identities in green. We've got the basic Pythagorean identities written in blue, and then double angle identities are written in red up there. All right, now let's take a look at an example. It says given sine of x equals -5/8, and then it gives us this weird interval afterwards, which says 3 pi over 2 to 2 pi. And that's referring to the unit circle, basically talking about which quadrant we're in. So if we remember anything about our radians, 3 pi over 2 to 2 pi, that's going to be quadrant 4. So we're looking for something over here. And it makes sense because it says sine is -5/8. Remember, sine's always the y values. So we have positive y values above the x-axis, negative y values below the x-axis. So it makes sense that this quadrant, sine is going to be negative. Cosine in this quadrant should be positive. So that's what we should see. We should see cosine is positive. Is a positive value in quadrant 4. We don't necessarily know what it is yet. But if we're thinking about if we were to draw a triangle, right triangle, and we know sine is opposite over hypotenuse, which is why we'd have the 5 and the 8 there. So if we have a right triangle, and we know one side length and the hypotenuse, we can find the other side length using the Pythagorean theorem. We can say 5 squared plus, we'll just call this x because it's the positive x-axis, plus x squared equals 8 squared. Well, we know 5 is 25, 5 squared is 25. We know 8 squared is 64. We can subtract 25 from both sides. We're going to end up getting x squared equals 39. And then we can square root both sides, and we're going to get x equals positive or minus square root of 39. But because we already talked about we're in quadrant 4, based on what the hint that was given to us at the very beginning, 3 pi over 2 to 2 pi, we know cosine is going to be positive, so we don't need to worry about this plus or minus. We just say, oh, the x value is going to be square root of 39. So we can label that on our triangle. So cosine would be square root of 39 over 8. That's how we'd write down our final answer here. All right, let's move on to example B here. We're trying to do our notes a little bit nicer this time. First I see this is going from pi to 3 pi over 2. That is telling us this is quadrant 3. All right, and we're starting with cotangent of x. Cotangent is 1/2. So again, if I'm thinking about quadrant 3 specifically, it's down here. I know sine is going to be negative value in that quadrant. Okay. I know that 1/2, if I were to draw a triangle here, back up to the x-axis, for tangent it would be opposite over adjacent, but for cotangent it'd be the reciprocal of that. It'd be adjacent over opposite. So we know the side closest to our angle theta here is 1. The side opposite of it is going to be 2. And then we have our radius that we're trying to solve for here. So I can start by saying 1 squared plus 2 squared equals r squared for our radius. 1 plus 4 equals r squared. 5 equals r squared. R equals plus or minus 5. And one thing we know about the radius is always going to be a positive number. So in this case, it's going to be 5. And what happens is, because we're in quadrant 3, we technically have a -1 and a -2 there. But what happens when you have -1/2, or -1 divided by -2, that becomes a +1/2, which is why the cotangent value was positive up here. So now, for sine of this angle theta, I'll highlight it for you. The sine of this angle theta down here, that's going to be opposite -2 over hypotenuse. So it would just be -2/5. That's how we'd find this particular problem here. All right, we'll do one more example here. This one's a little trickier. It says given that cosine of x equals 1/4, and this time it's saying I'm going to be in quadrant 1, 0 to pi over 2, 0 to 90 degrees basically, so the first quarter of the rotation. Find the exact values of sine of x. So in quadrant 1, I can go ahead and draw my triangle. It's going to look something like this. Here's my theta. Cosine is going to be 1/4. So I'm looking for that y value. So I could say 1 squared plus y squared equals 4 squared. So 1 plus y squared equals 16. Subtract 1 from both sides. Y squared equals 15. Y equals square root of 15. And in this case, it's going to be positive because I'm in quadrant 1. So to find the sine function, I would say square root of 15 over 4. That's sine of x, because it's just doing the opposite over the hypotenuse, square root of 15 over 4. For the second one, sine of 2x, that's a double angle identity. So I have to look at this and say, well, this is the same as 2 times sine of x cosine of x, which is what I've written up above. So basically, I have to know what sine of x is and what cosine of x is, and I'm going to multiply both of those by 2. It's just a simple substitution for this problem. 2 times sine, which I just found, root 15 over 4, times cosine, 1/4. It's just a simple substitution. Sine of x, we just solved for, root 15 over 4. Cosine of x, given at the very beginning, 1/4. And now I can just multiply straight across. 2 times square root of 15 times 1, that's 2 root 15. 4 times 4 is 16. And then I can simplify. 2/16, that's 1/8. So sine of 2x happens to be root 15 over 8. The most common mistake students make with this problem is they want to multiply this, just the sine, by 2, and they'll get root 15 over 2, but that's not the correct way to do that. So just be careful on those particular types of problems. I've got 2 practice problems down here. We'll practice 1 and 2. Try those problems out. Just go ahead and pause the video right now and give them a shot. Alright, so if you're ready now, problem 1 is kind of a trick question because the sine of x equals 3/7. Find cosecant. Well, that's just the reciprocal. So instead of doing opposite over hypotenuse, you're doing hypotenuse over opposite. So cosecant is simply 7/3. You don't even need to find the third side of the triangle. For problem 2, tangent of x equals 1/2. So you're in quadrant 1, and you know this is going to be 1/2. It's opposite over adjacent. So you're trying to find that radius, the third side, so you can do the secant. So we can do 1 squared plus 2 squared equals r squared. We're going to get 1 plus 4 equals r squared. 5 equals r squared. R equals square root of 5. So for this particular problem, to find the secant of x, we can say, okay, so secant is related to cosine. Well, cosine is going to be adjacent over hypotenuse. It'd be 2 over root 5. Let me go ahead and do cosine first. Cosine of x is 2 over square root 5. So secant of x would just be the reciprocal of that, root 5 over 2. That's how we'd solve that type of problem, using these trig identities and simplifying. I got 2 more examples for you guys today, and then I'm going to let you go on the assignment. So solving each equation, we're kind of putting everything together here. I'm going to give you an interval, okay, which we did a little bit of this practice a couple classes ago. and then we're going to go ahead and solve. So this first one is root 2 sine of x plus 1. I got to get sine of x by itself. We're going to start with that first. So I'm going to subtract 1 from both sides. And then I'm going to divide both sides by square root 2. And I have a radical in the denominator, so I don't like that. In order to get rid of a radical in the denominator, I got to multiply both the numerator and denominator by 1. And this ends up being negative root 2 over 2 when I simplify it all out. And now I'm thinking on this interval from negative pi to positive pi. So if I'm looking at the unit circle here, starting here at negative pi, and I'm rotating in a positive direction, one full circle, all the way back to positive pi. So I have to think about when sine in the unit circle are going to be negative root 2 over 2. Sine's going to be negative in quadrants 3 and quadrants 4. So if I were going from 0 here and I'm rotating in a negative direction, and there's going to be 1 negative pi over 4 there. That's where one of my sine functions is going to be. The other one's going to be at negative 3 pi over 4. If I rotate in a positive direction to pi, I'm never going to cross those axes again, so those are my two values right there. So sine of x equals the ratio negative root 2 over 2 at two different radian values. That's going to be when x equals negative pi over 4 and negative 3 pi over 4. Those problems are really tricky. I mean, Mr. Jolly and I have had a lot of practice on these over the years. But for you guys, this is really hard to do online. So please, please, please make sure you're trying to come to office hours, trying to get better at these. These types of problems are real good examples of what you could see on an IB exam if you're planning on taking that thing next year. All right, last example today, we have 2 sine squared of x minus 3 sine of x plus 1 equals 0. And this one, thankfully, is just on the interval 0 to 2 pi. So just one full rotation around the circle. Nothing tricky about that, hopefully. So I start with this 2 sine squared of x minus 3 sine of x. This is something Mr. Jolly talked about where you might want to rewrite this as just like 2x squared minus 3x plus 1. And we just want to factor this. For example, I know there's going to be a 2x and an x. And these two numbers are going to be 1 and 1 just because the factors of 1 are 1. And I need to get a negative 3, so it's going to be 2x minus 1 and x minus 1. That's one way to think about it. But I have to put those signs back in there. So this is really 2 sine of x minus 1 and sine of x minus 1 equals 0. And then using zero product property, I can say, well, let's write two different equations. One of them's 2 sine of x minus 1. The other one's just sine of x minus 1. And those ones equal 0. If I solve for the first equation, I'm going to get sine of x equals 1/2. The second equation, sine of x equals 1. So I'm looking for when the y value equals positive 1. Well, on the interval 0 to 2 pi, that's going to happen at pi over 2. When this thing equals positive 1/2, that's going to happen somewhere in quadrant 1, somewhere in quadrant 2. And I might need to bust out my unit circle from a previous worksheet. But I'll say, hey, there's 1 when x equals pi over 6. 1 when x equals 5 pi over 6. And then for this one, we already said it was pi over 2. So our final answers for problem B, x equals pi over 6, pi over 2, 5 pi over 6. Your assignment tonight is just practicing these types of skills. This is kind of putting it all together. This is kind of the last thing we're doing with trig functions. All right, and again, please, please, please email, reach out if you have any questions, set up an appointment for some office hours.